All right. Hello, everyone, and welcome to the Air Devils meeting of the 12th of November, 2020. Uh, First off, we have a design all prepared for our shirt that will be ordered and printed sometime in the near future, and we'll hope to get that out to you soon. Uh, we have also submitted our design proposal a couple weeks ago, and we are now waiting to hear back on whether or not we have been approved for our shirt or approved for our proposal so we can actually compete in the competition. The shirt only plays a small part in that. Uh, so the goal of this meeting is to identify the different teams and sub teams that you all can be a part of in terms of actually getting into designing, building, and flying the aircraft, as we now have uh, approximately 5 months until competition. We need to design, build, and of course, test fly our airplane well before that. So, with that being said, I'll go over quickly our management summary of this. And it's basically that we have an executive leadership team composing of our faculty advisor, Professor Takahashi, the president, which is myself, and then various other positions like outreach coordinator, secretary, chief engineer, vice president, treasurer, and so on and so forth. Uh, Beneath them is the team leads, such as propulsion, structural design, flight sciences, and then there are sub teams beneath structural design in relation to the sensor retrieval mechanism, and the airframe itself. So starting off with the propulsion team, they are responsible for selecting the best propulsion configuration for our aircraft uh, in order for us to achieve the best score in competition. They have to make sure that we have enough static thrust to take off from our 100-foot runway distance, as well as maintaining that thrust with the lowest thrust laps through our multiple laps that we compete for both phases of the competition, as well as making sure that we can maintain endurance. So to do that, they balance the power of our motor, the amount of power that we have on board through our electronic systems, and the size of the propeller, which is tied deeply with how we balance our whole propulsion configuration. And that is being led by Max with assistance from Natish and some others. They are currently in the process of gathering test data with actual test flights on a propulsion testbed airplane, which we can then hopefully use that to help inform our choice of propulsion configuration for the competition airplane. Then there is the structural design, which is either headed by Christian or Ivan, I forget. They're both integral parts in that. And that is with relation to the overall structural design of the aircraft, how the different load paths travel through, what kind of materials we need, and what kind of construction we need to achieve in order to make sure that our plane doesn't fall apart when it makes a turn, or fall apart when it lands, or fall apart when someone sneezes in its general direction. All are highly we don't want that to happen at all with the relation to our airplane, but we also would like that to be just barely not falling apart, because that means that we have an efficient structural design that has less weight. And weight is the ultimate enemy of Air Devils, besides USC. Then there are the flight sciences teams. There, underneath the flight sciences team, there is the aircraft stability team headed by Kevin, uh, which is responsible for tail sizing in order to ensure that our aircraft has optimal stability characteristics, as well as the main aero team, which is Jack, Evan Barker, myself, Derek, a few other people, where we're currently designing the wing to have the optimal flight characteristics for our aircraft. Underneath the structural design team, are the different mission sub-teams, such as the sensor retrieval mechanism, and then the airframe itself. The sensor subteam is responsible for the design and implementation of our sensor, making sure it is able to complete all mission requirements, such as being able to be dropped from 10 inches, being able to properly have a daylight visible LED, that kind of thing, making sure it runs all the time and making sure it doesn't fall apart. Then there is the retrieval mechanism team, which is responsible for how we are actually going to deploy and then retrieve our sensor from the aircraft in flight before the first 360-degree turn, which is quite the challenge. I do not envy them, and they are already hard at work trying to figure out how to best go about doing that. Then uh, also in the retrieval team is the actual payload bay itself, which has to have a some sort of system like a bomb bay door that opens and closes around our sensor, so we can A, load it in the ground mission, and perhaps more importantly, B, actually deploy it in flight and make sure we have optimal drag characteristics during our mission 3 endurance mission. So yeah, and then of course the airframe team is responsible for the things that I mentioned previously of making sure that the airframe only barely doesn't fall apart in flight in a good way. So is Nitish in here? Oh no, not yet. He has a class at 7, I think. So Daniela, you want to quickly go over the work that you're doing on the bomb bay doors?
Yeah, so I'm one of the few mechanical engineers on the team, so I'm working on the bomb bay door mechanism. I'm also working with Sean Haney, who couldn't be here tonight, but he's also another mechie I know. And we're basically next week going to be prototyping with just a miniature version, but we're going to essentially do two balsa bomb bay doors connected to a push rods connected to a servo, which will be mounted somewhere in the fuselage. And then this could easily be connected to the radio, where you can just essentially hit a button and deploy the bomb bay doors that can open fully and then deploy the payload.
Mm-hmm.
So that's what we're working on. We have a design drawn up, so we're going to be messing around with servo size and batteries next week to see if we can get this, and then we'll start building the final bigger one.
Yeah, something like this.
Yes.
And if you would like to participate in that, the channel specifically for that section is the sensor kinematics area. There's some information in there revolving around what the payload bay has to do and some ideas about how to accomplish that. Yeah. And then Jack, you want to go over the sensor retrieval?
Sure. The sensor retrieval is a mechanism that's going to release the sensor. I'll slowly let it out, and then once it's fully deployed, leave it there, and then retract it. And in the mission requirements, it is required to remain stable during this entire operation. So sadly, we cannot seemingly drop it out and just have it on a line and then just reel it back in. We also have to have wires that are controlling it. So we're gonna have to figure out the best method to connect, well, keep a connection is it's the sensor's on a line and we have to reel that in, and we're likely gonna reel it in around a drum. But we're gonna need a cable to be leaving the drum, and it's drums rotating, and the electronics inside are not going to be rotating, so that's going to be a little challenge. We're going to have a motor that can hopefully reel it in at a safe speed, and the hardest part is once it's all the way fully deployed, it knows when to stop, and it also knows when to stop when it's all the way reeled in. And we can have part of the mission rules allows for a second RC controller, so we can have some manual control of it, but ideally not too much manual labor. Anything else I think I should add?
Man in the loop is always a good thing, but that also introduces the element of human error. And so we want to make sure that nothing gets too out of hand.
I kind of have I can share my SolidWorks design thingy. It's this is
Yeah.
one I haven't changed since
Here, let me make you co-host real quick.
yeah. Okay, here we go. So here's a SolidWorks design. It was just a very simple I threw together. But the idea is to have a drum. I'm thinking around 2 inches in diameter. Although I will be doing a little math later to figure out the best size. Then we have a motor attached to it. This one shows gears. That's probably not the best idea because gears are awful. And this is just a sample-ish frame. And the wire should be going, it's going to be directed some sort of simple pulley system down to the center of the bomb bay, and then attach to the sensor. And then when it's reeled out, I don't have it moving, but reeled out and then it reels back in. And so that's the general idea. And part of the mission is that we're allowed to move this during the cargo mission. So payloads, pylons like this right here. So we can design it so it can be moved out of the way. It still has to be in the plane, but we can move it out of the way so we can fit more sensors in the plane when we're not doing mission 3. So that all has to be taken into consideration. So it's definitely not going to be an easy task.
That is correct. Nothing about this is easy. They didn't throw us any bones. You guys, did Jack or Evan Evan upload his CAD that he made for their proposal anywhere?
I'm not sure.
Okay.
I can check right now.
All right. I don't think it's up there. That's fine. So, right. Max, do you want to talk about propulsion?
Yes. So Daniel talked about a little bit what we're hoping to do with this sub team. And he described that we're doing test flights and getting experimental data, and that's all for the purpose of determining the best motor, prop, battery setup for the whole competition, all of our missions. So the ideas that I'm having now going forward is we're going to adjust the current hardware that we have that we've been getting data from the past few weeks or so, adapt that so we can use it on last year's competition plane and even like mock-ups of this year's plane, so we can get experimental data from a faster plane, which is last year's plane, and the plane we're actually trying to fly with this year. So a lot of test flights possibly on the horizon. So if you are interested in going out in the field and actually seeing things fly, then this might be a good route for you. And then using those test flights to analyze the data files and get real hard numbers on what is good, what's bad, and have that contribute to our decisions.
Absolutely. Let's just suppress all missing components. So, that being said, I'd like to share my screen again, just for a moment, to talk about the aircraft structures team. So this is the aircraft design full CAD model from last year's aircraft, the 2020 competition. Don't mind that some things are misaligned. That's just a sad casualty of switching between versions of SolidWorks. Sometimes things get a little messed up, but that's all fine. So one of the jobs of the structures team will be to integrate our wing to our fuselage box. And if I hide that, you'll see that basically the structure, it looks pretty simple. You got a couple stringers or stringers. You got a central keel box that goes down the center of the airframe and then up and into the tail, made of carbon fiber. And we're going to ultimately do a fairly similar design for this year. But Ivan, you want to talk a little bit about the structures?
Yeah, sorry, I just got here. I was in class.
Don't worry. Kind of
So,
out of the blue for that, but
so yeah, we basically for this year, the structures are gonna be very different in the fuselage part because we now have to make space for the sensors and the pulling system that we're gonna make. It'll probably be really big or fairly big because it's 10 feet of cable, and also all the electronics. The wings will probably be very similar because we don't really need anything different there. I've been working on some sketches, trying to make something where instead of having one carbon fiber spar going through the middle of the plane, it's two of them that go through the sides. So this way we have all the space possible inside. And we also need to figure out ways to make it possible for all the other systems to connect to the main structure of the plane. The idea is to make it as simple as possible so that it's light and easy to manufacture and also easy to fix in pre-crash or something like that.
Also, yeah, you want to make it easy so you can analyze it because ANSYS is not the best.
yeah.
Also, from what I've been hearing, we're going to make it a high wing plane. So yeah, one of the main aspects is going to be how to connect the wings to the fuselage. And since we're going to be carrying a lot of weight, we have to figure out a good way to do that is also reliable. I don't think the rubber bands are going to work for this. Probably too much weight for that.
And we have a bomb bay in the way, so.
Yeah.
Yeah, the ultimate challenge of the airframe structure team is that everything wants to be close to the center of gravity, whether it be in the lateral or longitudinal directions. And so they have to sort of balance where everything is going to be in order to balance out the weight. Like, for example, the engines want to be close to the center of gravity. Whatever our payload mechanism wants to be close to the center of gravity. All of the airframe structure attaching the wing to the keel is going to want to be close to the center of gravity. It'll be an interesting challenge.
Yeah, I made a sketch, kind of like an idea I have. I'll send it to the Slack, see what you guys think, and let me know what I can change.
Yeah. Kind of like
yeah.
this.
Yeah. So it has that's how to connect it to the wings. I'm not sure about that yet because there's a lot of weight, but I've seen that in another plane I have back home. So it worked pretty well because it doesn't rely on rubber bands and it can easily be mounted.
Yep. Pretty easy to design a strong bulkhead that we then slot the wing into. That's how a couple of our previous designs ended up working out. So, yeah. Is Nitish in here? Yeah. The last team, I guess, I'm going to fill in for that leader because he's not here, is that there's the actual sensor design, which is less so a mechanical design team and more so an electrical, because the main challenge for that part of the design is that it has to have a whole bunch of electrical functions, such as having a flashing light mechanism that flashes in series, for example. And we just have to figure out how to fit that, its control mechanism, and of course the lights that have to shine so bright that they're visible in the Tucson daylight, in order to actually be able to compete well at competition. That's not to say there isn't mechanical or aero design elements in that part of the competition. Of course, we have to actually make sure that the sensor is stable. That was kind of one of the points of our sensor design competition that we had that kind of, I'll admit, kind of fell over into not really doing anything up to much. It's because it's a really difficult challenge to try and design a sensor that is able to do all those things and also be stable. And so that will be a team that will have to be doing a lot of testing, a lot of actual building, and a lot of prototyping in order to make sure that they're able to produce something that is able to work. So
Wait, some additional requirements on the sensor is we want to make it heavy, and so we're gonna want do the best on that. And currently we have, what is it, 10-inch sensor as our
yeah, we want to carry, just so everyone knows, our end design goal, our design point that we want to design for, design, is we want to have an aircraft capable of carrying 8 10-inch sensors, each weighing, I think, 3/4 of a pound, which is, again, a challenge of the sensor team, is that they have to balance how much weight they dedicate to systems and how much volume compared to how much volume we can end up filling with just lead shot in order to make the sensors as heavy as possible. And yeah. So does anyone have any questions about the different sub-teams? Or is there any that sound particularly interesting to any of you? Bryce.
I think I'd like to join the Slack for the airframes one for sure.
Okay.
I like the
Yeah.
windows.
I think on Slack you should be able to join any of the teams you want to stay informed of any of them too. So it's not like if you have to be on the team to join the channel.
Okay. Awesome.
Yeah. The Bombay one is the sensor kinematics team.
should retrievals be with that as well?
Yeah, Retrieval and Bombay are both in the sensor kinematics, but could probably do another channel for that to sort of more closely follow our design chart here, our team chart. And I guess while we're here, just so you guys get an idea of what kind of schedule we want to apply to, ignore the first prototype flight.
Yeah, we're just trying to,
Yeah, our detailed design will go throughout November into December, and then we want to build fully functional prototypes into January, then iterate on those prototypes in order to produce a mission capable plane in February that we then finalize over the course of March to have a competition ready in April, which is right here. So yeah, there is quite a lot of work to do, quite a lot of work ahead of us in order to get everything done. So yeah, to the team leaders that I've called out in this discussion, do you want to drop your emails in the chat, I guess, your ASU emails? And if you're interested in joining each of these sub-teams, I recommend you reach out to whoever the lead is of that sub-team and you can be part of multiple sub teams. But that is the best way you're going to get active in the club and get something out of your time here, is to be part of one of the sub teams and actually design something. Take a little bit of responsibility, and you will find yourself rewarded for it.
Yeah, we're not gonna do all the work by ourselves. We'd rather not do that.
Absolutely.
It's quite a lot of work. We delegate, so, and we'll make sure if you have you don't understand something, we can help you along.
Yeah.
Can you explain again a little bit about what comes in score optimization?
Sure. So for score optimization is what we did here. It was basically running a multidisciplinary model. Nope, don't want that. I want take off performance code 3.5. So that was a whole bit of computer coding and development that I've done over the course of the past month or so, month and a half, of building this tool that allows us to analyze our performance code, analyze aircraft performance based off of pretty decent assumptions in order to make get an idea of the design space, and from there actually come up with our competition design.
And okay, is that the one we used in AE 344?
Not really.
Oh, okay. Cool,
There's a
that's
lot
fine.
of similar things that we got from 344.
Okay.
Uh,
And we can be in multiple sub teams, right?
absolutely. I in
Okay.
fact encourage that. Be as part of as many sub teams as you want. But it's better to be really active in one sub team than it is to be existent in like 3 or 4.
Okay, makes sense. Thank you.
Yeah.
How much work will it be like assigned to like if you join one sub team? Because obviously I don't want to get like overwhelmed if I join like 2.
So
We
it's absolutely how much work you're willing to take on. In that way, it is not like an assignment. We won't be assigning projects to you. But if you are willing to, say, design, to give a previous year's aspect, if you're willing to design the radome of our 2019 aircraft, then it is expected that you are completing the radome for the aircraft on time for competition. If you let that slip, A, we'll be really disappointed, and B, we probably won't do well in competition.
how'd that work out for you, Daniel?
I was able to complete it. I probably took a little bit more time than I should have, and I didn't ask as many questions as I should have when I was going through the design. And so that's some wisdom I hope to bring on to you guys, is to ask questions and don't let things slip.
But you kept on working and got it done.
Yep, I got
Yeah,
it done.
looked good.
It looked really good, I think.
Yeah.
I wonder if I have
Didn't
it in my
fall
file
off like the
somewhere.
one team.
Yeah, it didn't fall off. It stopped spinning at one point, but we won't
And
talk about that.
it wasn't velcroed on like the other team.
No, in fact, it had
Yeah.
a finely assembled pin mechanism.
Yeah,
that,
that's 2 pluses right there.
made sure. Oh, whatever, rebuild. Look at that beauty of a design that I ended up making. It has. If
I think the biggest negative on this one, Daniel, was it weighed more than the bomb payloads combined. I'm pretty sure it was.
I'm not too sure about that. It was fairly light in the end.
I thought it was like 1.5 pounds or something. I don't know.
To be fair, it had quite a aero load on it.
Oh yeah, we found that out in the one prototype.
Yeah, at one point it stopped spinning, which was okay.
Sort of flopping around a little bit and
Yeah.
angling.
So yeah, this was my specific contribution to the team. It started as just a basically a dinner plate shaped object rotating on a servo, and ended up into this thing, which has a channel cut into it that allows us to put a bearing and a support pin to make sure it doesn't yank out the top of the aircraft. A bunch of support pins in here for quick release and attach for the ground mission. A servo mount here that then attached to a couple pulleys, did everything else. And yeah, do not underestimate how much can actually end up going into. Sadly, I don't have the wing on this computer, but it ended up being something like this, with this being a representation of the radome, but it seems to be missing some parts, probably from a file rebuild or something. But yeah,
Hopefully this missing parts problem will be ended with the GrabCAD.
absolutely. I think this is also having a little bit of version madness, because this is a late version, this is an early version, and yeah, make sure you have your files in a row. So yeah, make sure to ask the subsequent team leads any questions you have in regards to what their designs are, and if they don't know, then they can always run the questions up the ladder to me, and I'll be able to answer, hopefully. So yeah, I guess if you don't know, you can join a you can figure out what channels you can join by clicking on more, and there should be a channel browser option, and there are all of the channels that you can join or hope to join in
It looks
here.
different on the mobile device, just FYI.
Yeah, I bet it does. But this is, I use it on the PC, so you
Nerd.
guys don't want to see the leadership chat. Only secret information goes on in there. So yeah. Any questions, comments, concerns?
Is this a finalized modeling simulation now you got here?
Yeah.
Is it still saying 10-inch long, 8 payload?
Yeah. It's a little close on the takeoff, I'll be honest.
Ah.
But the good thing is that payloads are easy to remove and attach.
The other thing I was thinking with this, Daniel, if this is only the 3-minute mission or whatever, the last year we were only planning to do one battery, so we might be able to lose a little bit of weight and maybe have to move the payloads forward a little bit. But
yeah,
we should be able to get like an extra pound if we're only doing one battery and do 3 laps.
Okay.
I think that's what it should be.
Yeah, because our current aircraft payload assumptions is 0.6, and if our batteries weigh, what, 1.5 pounds each?
I think there should be like
Approximately.
1.1.
These are with the 6 cell. These are with the 100C 6S.
Oh, are they that
FWC.
heavy?
This was, I think, what you got as the weight for these.
Oh, I don't know. I
I'll
thought they were
double
like
check that.
1.1 or 1.2 pounds. But either or.
Yeah, we should be able to get a couple more payloads by dropping a battery on this mission, but that's not something
Or
this.
a little better takeoff distance if that's necessary.
Yeah, because 82 is it's a good. There's 20 feet of safety margin, but
Yeah.
yeah, it's a little close. We'd like to have a 75-foot takeoff.
What's the stall speed for that mission?
The stall speed, hopefully, will be 30 knots.
Okay.
And a top speed of 66 knots.
Oh, that'd be moving.
And that is with the 400 kV 6S on a 16x10 prop.
Okay.
So the 6S is a little there because it's also using the 6S for mission 3, which isn't the best, but
Yeah, well, we'll get it good enough.
yeah. Good
There's
to
so many
know.
other things to get to get working on this. It's like they gotta sacrifice a little bit.
Yeah, you have to reduce complexity where you can,
Yeah.
and this is already fairly complex of a simulation.
I agree.
So, yeah. Hopefully, we're able to achieve a overall score of 415 based off of a good mission 2 and a okay mission 3. But the ultimate challenge is if we aren't able to complete mission 3, then this becomes a 0 and our score is halved.
Yeah.
So that is the importance of these sub teams. Specifically, is that they're pretty much all focused on mission 3. While our design is a little bit focused on mission 2, mission 3 is the most important mission for us to complete. Get whatever score we want on it, as long as we complete the mission satisfactorily. So, yeah. If there are no questions, no comments, no concerns, I'm willing to end the official meeting there and stop the recording. Where is the stop recording button?